In this presentation, we're going to take a quick look at something called sampling, something that is very important if you want to conduct any kind of experiment to collect data. How you collect data is often more important than the way that you analyze it. Not that analyzing it isn't important, but the collection is often a huge deal, and choosing your data incorrectly or poorly can lead to results that are meaningless or useless. Just before we go, I put this picture on the slide for a very specific reason that has to do with sampling. And I just thought I'd share with you the first time I ever presented this, I asked students what this was in the picture. And someone said it's a turtle. And I'm like, yeah, but what is the thing on its back? And another kid put up their hand and bless their heart, I felt bad laughing, but I could not stop myself. They asked if it was a remote control. And it is not a remote control turtle because that's not how remote controls work. And honestly, that's not how life works. I can't just slap something on an animal and then have a remote control for it. If I could, that would just be awesome. But that's not what this one is. This one's actually a tracking device that lets me follow the turtle's position and possibly other things. It might record, for instance, like um, the amount of light in the water. It could collect the depth that the turtle's in. It could collect the temperature of the water and so on. But it's collecting information about the turtle's surroundings and or the turtle. Now, I will confess that I'm not enough of a biologist to know. Maybe this thing's got a heart rate monitor on it. I have no idea. But it's definitely collecting some information about the turtle and or its environment. So what we need to talk about in this lesson specifically is sampling techniques and how sampling works. So the big reason that, actually, let me back up for a second. When we collect information, we can collect information from either the population or a sample, which are words that we're going to get to a little bit more detail in a moment. Population basically means everyone, sample means part of everyone. It is very hard, very costly, and very time consuming to collect data from everyone, depending on what that situation is. And I will point out that I'm often in this slideshow going to refer to everyone like I'm collecting data from people. But this could be the population of frogs in a pond. It could be the population of oak trees in a forest. It could be the population of Star Wars figures that are being produced in a mass assembly line. Like it could be just about anything. I often will refer to it though as people. And when we get to collecting information from people, obviously that's very specific to people. But these other terms like population and sample can refer to anything pretty much. The key feature here though is that it would be great if we could collect information from everyone or everything we're doing a study on, but it's not entirely realistic. Okay, populations. Uh, you probably heard this word possibly in grade 9 or 10 science, and you talk about, the population again of frogs in a pond. Population can be anything you define it as long as you specifically define it. So for instance, if I wanted to say, what's the favorite television show of grade 9 students? Most people would have some sort of opinion on that, but it's probably important to define that I'm probably am referring to grade 9 students in our area or maybe in Ontario or Canada. If I was looking at grade 9 students worldwide, I may not get the same answer as I would if I just did it in Kitchener-Waterloo or Ontario. So we can define the population however we want, but we should be specific about it. If I'm defining, again, what percentage of frogs are born with birth defects? Am I talking about all the frogs in a pond, a specific pond? Am I talking about all the frogs in a continent? Am I talking about every frog in the world? Because again, the results will be quite a bit different or maybe quite a bit different. And my study should only reflect what I'm actually working with or trying to work on. Now, I will bring up the example specifically that's in this slide because it's going to follow through a couple of the things that we're looking at today. In this particular example, we might want to know in the school how many of our students want to order a yearbook, and we would define the population of the population in this study as all of the students at the school in question. We don't want to say of all students because we could be talking about all the students, for instance, in the Waterloo Region District School Board. And since all schools individually make their yearbooks, I don't think we need to know what percentage of students overall buy yearbooks. I need to know how many students at KCI are going to buy a KCI yearbook and how many students at Eastwood are going to buy an Eastwood yearbook, and Glenview Park and all the other schools individually. So now that you know what a population is, we know that it's really hard to collect information from an entire population. So what we want is a sample, which is just going to be a subset of the population. By the way, subset is going to come into play later. We're going to talk a lot more about sets in another unit. But for now, it's just a small part of the population. Or I shouldn't say small, it's any part of the population. It could be up to and including the entire population. Um, if the population was I wanted to know what the favorite flavor of ice cream of my nieces was. I only have two of them. It's pretty easy to collect information from the entire population. If I wanted to know again what percentage of students at school wanted a yearbook, it might be very hard to collect that information from each and every one of our 1,500 students at my school. That's actually a little bit high. I think we're about 1,200 or something like that, but you get the idea. So we start with the population, and then we want to take a sample of that population. How we collect that sample is very important to give us the results that will be meaningful and useful to us. So I've mentioned these three things before, but I'm putting them on again. And by the way, anything that's in yellow on these slides is probably terms that you want to know or make reference to. And here's an example where we're going to go to a rock concert and we want to know something about these people at the rock concert. Maybe it might be, what percentage of people at the rock concert want to buy a band t-shirt, so that I know for future concerts roughly, how many t-shirts I should have produced and bring to the concert with me to sell. Well, if I was going to try and collect information from the entire population, I would have to go around to every single person at the concert. And I think that you can appreciate that if I wanted to do that, there's no way that I'm going to personally be able to ask every single person during the concert. I won't have time to do it. So that brings to the first point of trying to sample the entire population is way too time consuming. In order to do it, if I did want to get it done in the hour and a half, 2 hours, 3 hours, whatever of the concert time, I would have to hire a bunch of people to help me out, which would be extremely costly. That's our second point, or second reason we don't usually collect data from entire population. And the third reason is it's too difficult. So if I did hire a bunch of people, there were 100 of us going through the crowd trying to collect information, how many times is the same person going to get asked the questions over and over again and be like, someone already asked me, leave me alone? Or the other part is, how do I know I got everybody? Do I tag them when they do I know everyone's there? I just tag them whenever they get asked a question, so I know everyone's been checked. Or what if some people were in the bathroom when I checked and then came back to a section I'd already done? So it's extremely difficult to make sure that you've actually got the entire population. By the way, there is a name for sampling the entire population. It's called a census. And you may have heard that in reference specifically to like the Canadian census, where they try to collect information about every individual. And even in the Canadian census, they don't actually collect information from everybody. They're always going to miss people who are homeless. They're going to miss people who could be possibly in the country illegally, who are obviously not going to confess to, there's extra people in a household. They're just going to kind of list the people who are in the country legally. It could be people that just don't feel like telling the government stuff, that either lie or downplay information about it. So collecting information from an entire population never actually works well unless the population's small enough size or defined in a small enough way that it makes sense. So for instance, I can usually sample my entire class if I define that as my population, because I see every kid. And even then, sometimes it's difficult because, I've got someone who doesn't show up on a regular basis, or someone who just doesn't want to answer the questions, or whatever. But it's at least feasible for small groups, but not always reasonable. All right, here's the biggest question in the course that I cannot answer for you. How much is enough when it comes to sample size? And the answer is it depends on a bunch of things. The general consensus is that if you get more people or more things in your sample's a bigger percentage of your population, the bigger the better. However, you have to balance a large sample size with the problems that we just discussed about the time that you're putting into it, the cost you're putting into it, and the difficulty level that you're putting into it. So the more you get, the more reliable your results will be. However, here are some considerations that you might want to take into account. So the size of the population. With a very small group, you may need to collect information from pretty much everybody in order to get a reasonable thing. So for instance, if I wanted to know the average age of my nieces, again, I only have 2 nieces. If I sample one of them, that's 50% of the population. And yet I have a feeling that I'm going to be way off on my result. The average age, if I only sample one of them, will not give me a good representation when I have 2 of them. However, if I wanted to know the average age of grade 9 students in Ontario, I could probably get away with sampling 1 or 2% of the population. If the population is really large, a smaller percentage is acceptable. The other thing I want to do is look at variability of the population. And again, this one's really hard to define how much it impacts it. So all I can say is that more variability, you're going to want to try and sample more things. So just as an example of that, if I take a look at all the cats and all the dogs in Kitchener, and I say I want to know the average weight of a cat, I can probably sample less cats than I would dogs, or less percentage of the population than I would for dogs, because cats don't have a wide variety of weights. I'm not saying they don't change in weight from one to the next, they obviously do, but dogs have a much greater variability. The size of a dog, whether it's a newborn Chihuahua or a full-grown, like, what are they called? The Mastiffs, the big ones, the Clifford, the big red dogs. And I know that's technically not a real dog, but anyway, you get the idea. Dogs change in size quite a bit. Cats are roughly the same size. So we would want to sample more from the group that has the higher variability. The degree of precision required. If I want extreme accuracy, I have to have a much larger sample. If I'm just looking for a ballpark, then by all means, a small sample size is probably good enough. And then the last one is the sampling method chosen. Depending on how good my sampling method is, I might be able to get away with a smaller sample size. Usually we don't worry too much about this one though. And we're going to get into sampling methods in just a moment. Okay, so here's just another example of what I mentioned on the last one. If I want to know what percentage of people in Ontario are female, I could sample maybe 10,000 out of 13 million, which is less than 0.1% of the entire population. And that one there it's because I'm expecting very little variability, meaning I don't think the male to female ratio in Kitchener is going to be that much different than the male female ratio in Guelph or London or Simcoe or wherever. I think they're going to be pretty consistent. Whereas if I want to know what how many the 30 people in my class of sushi or my class of sushi, how many people in my class like sushi, if I sample 10% of that population, now keep in mind for the first one that we did at the top there, 0.1% was enough. Here, I'm going to sample 10% of my population. That's 100 times bigger sample size by percentage. But if I only ask 3 people in my class, do you like sushi? My only answers I can possibly get from that, or my only conclusions, is it's 100%, 67%, 33%, or 0%. And that's just not enough information to get a good feel for it. So I may actually have to ask just about everybody. So going back to the one rule that I can say is generally a good idea when you're trying to collect data is that the larger the sample size you can collect, the better. And of course, we have to balance it with the fact that we live in a real world and that we have limited time, limited resources, and everything else. So keep that in mind. Okay, now getting into the sampling methods. The idea of a sampling method is how do we choose our sample size? It's not how many, it's which ones do we take. So just an interesting example this morning that came up that I can give as a real concrete example. I like to have a smoothie in the morning, a protein smoothie, and I put berries in it. And I have a bag of mixed berries that I took out of the freezer this morning. It's a new bag of mixed berries. And it's got raspberries, blackberries, blueberries, and strawberries in it. And when I opened it up and dumped them out, I don't think I got a single strawberry or blueberry this morning. I think I just got raspberries and blackberries. And it's because for whatever reason they filtered to the top of the bag and the other stuff filtered to the bottom of the bag. Could be because of size or shape or weight or whatever. I don't know. But they did. So if I just said I'm going to open up this bag and I'm going to take out 50 of the 500 berries in there, that's 10% of the population, but I just chose them from the top, I would get a very disproportional number of raspberries and blackberries that are in the bag. I would conclude that it's like 50% raspberries, 50% blackberries, and that's nowhere close to being correct. So I have to choose my sample. I have to decide how I'm going to choose my 50 berries in a way that best gives me the results that reflect what's actually happening. Okay, so for our school example, for the yearbook, we're going to try and sample 60 kids from our school of 1,500. Now the question is, how do we choose those 60 kids? And let's take a look at some specific methods that we can refer to and talk about kind of their pros and cons and how they work. The first one is called a simple random sample, and this should, in almost all cases, give you the best possible results. It's where you basically take every member of the population and then you randomly choose however many people you're going to choose from it. There is no preference given to any one individual, and no individual chosen affects who else can be chosen. So it's completely random. The best way to think about this one is take all 1,500 student names, put them on sheets of paper in a hat, and draw 60 names from it. No one has an advantage. No one has a disadvantage. There's no, it works just fine. So that's the best possible thing that you can do if you want decent results. Now, I've always had the argument from students that, well, what if the sample chosen does not reflect the population? What if everyone chosen is tall, or everyone chosen is male, or everyone chosen is Asian, or everyone chosen hates ice cream? Those are all possibilities. That's just an unfortunate thing that happens, but it doesn't mean that we chose wrong or we used our method wrong. It's just a fluke that happens, and it statistically doesn't happen very often. There's always a possibility it will, but it doesn't happen very often. Okay, the next one that we're going to look at is called a systematic random sample, and it's almost as good as just a random sample, a simple random sample. It's just easier to do. So that would be, I would take everyone in a group, and I would say, for instance, choose them on regular intervals. So I could take randomly pick one kid from the class, and then every third kid after that, if I wanted to sample a third of my class. It doesn't technically follow the simple random sample definition, because if I choose the second person, like in this picture down here, and then every third person, as soon as I chose that second person, it precludes the first and third person from being chosen. In fact, it precludes anyone who's not a multiple of 3 higher or lower than that person. So it does actually break the rules, but it does actually produce a pretty good sample, and it's usually easier to do. So just you and every third person after you, that's who we're going to choose. A stratified random sample. This is basically trying to do a simple type of random sample, but in a more structured way, where we make sure that we're getting representation from groups that matter. And when I say groups that matter, I mean relative to the kind of experiment or questions that I'm asking. So I could stratify people based on their gender, based on their age, their education level, or just about anything else that I wanted to, depending on what kind of question it is. So for instance, if I was asking your age for my grade 9 class, it probably doesn't matter who I ask. Um, as far as, well, okay, what if I categorize them by age? But it probably doesn't matter what gender they are or what their ethnicity is. However, if I ask them what their favorite type of music is, that could be dependent on things like ethnicity, background, gender, etc. So I'm just going to go over to the picture here of a stratified random sample, and hopefully this will make more sense. So here's whatever it is that I'm trying to collect information about from this group of people. I think that maybe it might be gender specific. So music, favorite type of music, favorite television show, favorite color, whatever. I think that it might be dependent on gender. So what I do is I say, okay, the population is, in this case, 50% male, 50% female. So I'm going to choose 50% of my sample from the males and 50% of my sample from the females. And in doing so, I'm trying to stratify or break the group into what I think are relevant categories and then choose representative numbers of each of them. So uh, just as an example, at the school I teach at, we have a large Syrian population. And so I'm going to just make up numbers here. I have no idea if they're correct, but let's say that of 1,200 students, 200 are Syrian, 1 out of every 6. If that's correct, then I want to make sure that 1/6 of the people that I sample are Syrian and 5/6 are not Syrian. And I could do that again based on just any number of things. I could say that grade 9s make up 28% of our student body, so I want 28% of my sample to be grade 9s, and so on. By the way, I should point out here, just to be sensitive, is that in this example, I did mention that the population is broken down into male and female, and I realize that that's not taking into account several other categories in the LGBTQ plus community. I don't mean to exclude them. I'm trying to make the examples as straightforward as possible. If you have concerns about any of that kind of stuff, just please let me know and I will do my best to address it. I'm just trying to make the questions as straightforward as possible, which often means binary answers, unfortunately. Much like the Syrian example I just gave. I recognize there's many ethnicities represented, but if I start breaking down the population into the 40 or 50 represented ethnicities in my school, it becomes a very long example. Okay, cluster random sampling. So this is again sort of like random sampling or simple random sampling, except I want to break the population down into clusters or groups of people and then sample the groups. So I will flip over here and the picture, as bad as the picture is, I think it actually is fairly easy to understand. So let's say that my school we've got 12 groups there, had 12 grade 9 math classes. Actually, I want to be careful because math, whether we're streamed or de-streamed, makes a difference. I'm going to say grade 12 data classes. Oh, I wish our school had 12 grade 12 data classes. That would be awesome. But either way, here's 12 grade 12 data classes being taught at our school. And what I might say is that, you know what, the kids in any given data class are about the same. They're all pretty much the same age, the same level of education, the same interest in this. I don't think that one group is that much different than the other. So what I can do is just say of these grade 12 classes, instead of going around and trying to sample a few from each class, I'm just going to choose 2 of the classes and run my experiment with them. So basically I'm breaking the group into clusters where all the clusters are very similar and then just choosing a couple clusters as my sample. And then the final kind of sample type, which is the one that everyone actually uses. in the real world, unfortunately, is a convenience sample. And it's literally you just go out and get the first people that will give you an answer or the first things that will give you an answer. And it tends to not give as good results as the other methods that we just talked about, but it can give decent results as long as you kind of purposely try and keep things in mind. So you may be kind of using the ideas of the other things, just not formally doing them. And just as an example, something I would like you to think about is if we wanted to collect, again, information from 60 students about whether or not they want to buy a yearbook, I have a couple options. I could go stand outside the cafeteria at lunch and ask the first 60 students that pass by there. I could go to the school smoking area, or I could go outside the student activity office or inside the student activity office. And no matter where I go, I can still talk to the first 60 students that pass by. The question is, which of these will give the best results? Or are all of them going to give different results for whatever reason? Actually, just take a moment and think about that before I go on to the next slide. If you want to pause it for a moment and think, that's great. But otherwise, I will continue. Okay, let's start by taking a look at our first one, our going out to the smoke area. I think that one's going to be our biggest problem. And again, I hate to stereotype, but when it comes down to it, and I'm going to keep emphasizing this as well, there's a difference between stereotypes and statistics. A stereotype is when I try to apply a statistic onto a single individual. A statistic is just a mathematical conclusion. So for instance, it's not racist to say that there are, Asia is filled with a lot of Asians. That would not be incorrect. That is absolutely true. In much the same way that the boys basketball team is mostly male. That would also be true. Again, I'm not a sexist thing. What is not true is when you try to apply a statistic onto an individual. And there are some common ones. And again, I don't want to get too controversial here, but there are some very common ones that are arguable, but not necessarily used properly. So, for example, and I say this as an actual statistical fact, is that a lot of contest winners for math contests in Canada are Asian. That is a statistical truth. It's not a judgment call. It's not an opinion. It's just a fact. If you don't believe me, you can Google any math contest results, read the names. It's not hard to figure out. What would be something that would be a stereotype that is hurtful is to say, you're Asian, you must be good at math. Or you're not Asian, you must not be good at math, etc. That's trying to apply a statistic onto an individual. And it's really no different than if I walked into someone's classroom and said, hey, this class is 2/3 female, which may be statistically true. And then saying, so you, pointing at a random child, you must be female because the stats say that most of the class is female. Well, that you can't apply that statistics onto an individual. The individual is or is not female. I mean, there's just, you can't apply the stat. So that's a big difference between stereotyping and applying statistics. So statistically, students that hang out in the smoke area tend to have lower grades. That doesn't mean that the top marked student in the school can't hang out in the smoking area. It doesn't mean that the nicest kid in the school can't hang out in the smoking area. It's just statistically, students that hang out in the smoking area tend to be a little bit more disengaged from the school atmosphere. So if I went there and asked who wants to buy a yearbook, my guess is I'm going to get a lower representation from that group than the actual representation from all the students at the school. So let's pretend that the magic number is 70%. 70% of students want yearbooks. The students in the smoke area, maybe only 50 or 40% of them want yearbooks. So then I say, okay, let's try something else. Let's go to the activity office and see who does it. And by the way, I think the last picture and this picture, I'm probably dating myself a little bit. But, here's a group of a whole bunch of people who are highly involved in school. And that's usually who hangs out in activity offices. So if I went to that group, I'd probably get about 100% of people saying they wanted to buy a yearbook because they're the ones that are invested in the school, they're invested in the kind of activity culture and so on. So they're probably going to give a disproportional result compared to what we're looking for. So I would argue that of the three options, probably just going to the cafeteria and asking. There's no reason why people going past the cafeteria are going to want a yearbook more than the average person or less than the average person. And finally, I just wanted to put this in about drawing or making bad conclusions. Um, I do like the cartoon here. The research proves tall rats are more confident than short rats. At least I think it does. I've never been good at this, says the short scientist. Um, so choosing a bad sample size can lead to bad conclusions. That's just the way it is. We can have horrible, horrible results if we choose our sample size badly. Just as an example, if I was talking about, what's your favorite food? And I asked everyone in my class, and I'm like, just to make it easy, I'm just going to ask the first 5 kids on my class list. Um, well, as it turned, the one semester that we actually did do this experiment, I tried it, and it was actually a fluke. I didn't intend it to turn out this way. The first 5 kids on my class list were all Muslim because the first 5 people on my class list all had names starting with Al, A-L. Um, and as a result, I got basically 100% of my population enjoyed Middle East food, which is not necessarily true. Um, maybe it is. Maybe 100% of people do like Middle East food. I happen to love Middle East food. It's delicious. It's so tasty. But the point is that that was not a great sample to choose from. I've also done things too where I said, okay, rather than do that one, let's choose everyone with the last name who starts with an M. And as it turned out that there were a high number of students in the class that were mix or max, which means Irish or Scottish descent in general. Um, so again, that may not have been a great sample size. There's a whole bunch of ways that it can be done poorly. But the results are pretty consistent. If you choose a bad sample, you're going to make lousy conclusions. And I thought I'd just finish this off by talking about the title slide again, the idea of tagging animals. And really tagging animals is choosing a sample of the population. And in most cases, unfortunately, this is done by convenience sampling. The ones that get tagged are the ones that are found, the animals that we catch. They don't say, okay, well, there's a herd of reindeer. Let's find all of the reindeer and then randomly take, 25 of them. They just like, which 25 can we actually get? They're the ones that are getting taken here. And just to finish things off, I thought I'd leave you with a slide of improperly tagged animals. And for those of you who are worried about the horrible mistreatment of animals in this, I just want you to know that these polar bears were photoshopped with gang tags on them. And of course, that's not the kind of tagging we're talking about. Anyway, I hope you enjoyed that, and I hope you have a great day.